Welcome you all once again to my channel. So far we have completed exercise 5.2 and we have learned how to use chain rule. So let's start with the exercise 5.3, and it's an easy one because there it involves derivatives of implicit functions as it's already written on the sheet. So let's start with what implicit functions are and how to derive them. In your book, I will take the same examples as in your book. In your book, the examples are given like there are two functions written over there. X minus y minus pi is equals to 0 and x plus sine x y minus y is equals to 0. Now, out of these two functions, one is explicit and one is implicit. The first one is explicit because we can find the value of any variable. Like if we want to find the value of x, then it will be equal to y plus pi, and if we want to find the value of y, it will be equal to pi minus x. Clear? But in the second function, we cannot separate x and y because it's involved in the angle of sine. We cannot separate x and y. This is why it's known as implicit. The word implicit in a layman language also means to be involved in, to be included in something. Okay, so that's why sin xy, it can't be separated. That is why it's an implicit function, and the first one is an explicit function. To derive an implicit function is very easy. You just have to differentiate the whole equation with respect to x or whatever variable is given in the statement that you have to differentiate with respect to. So we'll be starting with our examples without wasting any second because it's very easy to derive implicit functions. So let's start. Our very first example of exercise 5.3 is example 24, in which it's given that we have to find dy upon dx, the differentiation of y with respect to x. Okay, and it's given the equation is x minus y is equals to pi. Pi is a constant and x and y are variables. Now just look at the thing which is required over here. Dy upon dx, we have to find the value of y. What will be y equal to? Y will be equal to minus y will be equal to pi minus x, or y will be equal to x minus pi. Clear? Now just differentiate the whole equation as a whole. You will get with respect to x only because the requirement is with respect to x. So don't forget the requirement. Okay. Dy upon dx will be equal to, now differentiate these separately, dx upon dx minus d of dx of pi. Clear? Now the differentiation of x with respect to x is always 1 and pi is a constant. The differentiation will be 0. So dy and dy upon dx comes out to be 1. This is how to derive a function like this. Now you must have noticed that this is not an implicit function, this is an explicit function. That is why the derivation was very easy, and we will be differentiating an implicit function in the next example as it's given. There is also an alternative way given to just differentiate it as a whole and then differentiating on both of the sides. It's also very easy, but it's not required to do two methods of only single sum. That is why we will not be doing the alternative method, but you can have a look, and if you find any problem, you can contact me, or you can literally drop it in the comment section. So let's move to our next example, that is exercise 24, and it's actually an implicit function given over there because we cannot separate the variable y, and the y is involved in the angle. So let's write down the example 25th. Example 25th is we have to find dy upon dx, and the equation that is given is y plus sine y is equals to cos x. Now the thing over here is that we cannot separate y from the angle. We cannot just exclude it from the sine. Okay, so that is why we will consider it as an implicit function and we will differentiate it as following. Now we have to differentiate y with respect to x, but there is no particular value of y. That is why we will just differentiate it as a whole equation. So just differentiate on the both sides separately. Firstly we will differentiate y with respect to x, then we will differentiate sine y with respect to x, then we will differentiate cos of x. Clear? We have divided all the three functions separately with respect to x. Clear? Now dy upon dx will be remained as dy upon dx. What will be the differentiation of sine y? Now just have a look over here. Consider it as a composite function as well, because sine as well as y, firstly we will differentiate sine and then y, and ultimately after applying chain rule you can see that we will get cos y and we will differentiate y again with respect to x, so we will get dy upon dx. You can apply a chain rule on this function just by taking v of u of y in this case, and f of y will be equal to v of u of y, and in the same steps that I have followed in the previous videos of applications of chain rule, you can solve it very easily. So if you have not seen the previous videos, I really recommend you to see the previous videos of chain rule applications and you can solve it very easily. So on the right hand side, cos x differentiation will be minus of sin x. Now we have to find dx, so we have to separate dy by dx ultimately. So take out dy by dx as a common. 1 plus cos y will be remaining in the bracket, minus sin x will be there, and what will be dy upon dx equal to minus sin x upon 1 plus cos of y, because this is being multiplied over here, and when it will be transposed to the other side it will be divided by minus sin x. So this is our ultimate answer. So this is how to find dy by dx. Just don't worry that how will we separate, just solve the whole equation, differentiate the whole equation, and then take out the dy by dx as a common factor. You will easily find your answer. The next concept in the same exercise is derivatives of inverse trigonometric functions. There are very clear formulas given of inverse trigonometric functions in your book, but for your convenience I will write down some that are given. If you differentiate cos of inverse x with respect to x, you get the answer as minus 1 upon under root 1 minus x square. If you differentiate sine inverse x with respect to x, you get 1 upon under root 1 minus x square. This is sine x. Now if you differentiate cot inverse x with respect to x, you will get minus 1 upon 1 plus x square, and if you differentiate tan inverse x with respect to x, you get simply 1 upon 1 plus x square. When you differentiate secant inverse x with respect to x, you get 1 upon x under root x square minus 1, and when you differentiate cosecant inverse x with respect to x, you get your answer as minus 1 upon x under root x square minus 1. So these are the formulas of differentiation of inverse trigonometric function which you can directly apply in the exercise 5.3, and you can solve the sums very easily. So with this concept we are done with the exercise 5.3 as well. So if you haven't subscribed my channel so far, I would really recommend you to do that in order to get new updates on a regular basis. If you have any doubts or queries regarding any of the questions, feel free to drop it in the comment section. Thanks for watching and complete your exercise. I am sure that after watching this video it will surely help you to apply these concepts in the sums of exercise 5.3 as well. So best of luck with the practice.